Hey there, it's Mr. Metters. Um, just for fun's sake, every time I record these, I sometimes do a bunch at one time. So if you see me wearing like the same shirt or outfit, it's not because I only have one shirt. I've got other shirts. Anyway, so today we're talking about place value, and we're talking about powers of 10. So before we jump into our notes, so this is the note sheet that we're going to be looking at. We're going to be talking about this anchor chart. Okay, so obviously I can't hang up an anchor chart in front of you, so we've got one right here that we've used in the past to go over. Now we're talking about powers of 10. So that's what you see right here. It says powers of 10. Our number system is based on a base 10 system. So you've probably heard of base 10 blocks and things like that. But what that means and what I want you to learn from today's lesson is that every time we move one place to the left, the number is getting 10 times bigger. So what you need to know right now is there's a difference between a number and a digit. So a digit are the things like 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Those are digits, but when we put them in a specific place, they have value, and then that's an amount, and that becomes a number. And it's very hard to understand because you're like, well, 0 is a number, and 1 is a number, and yeah, they can be numbers, but they also can be digits because a 1 in the tens place is worth a different amount than a 1 in the millions place. So that's where the powers of 10 come into play. So we're going to talk about periods. Now, whoever the math genius, let's call him Dr. McMathyton, I need to do some research to tell you who is actually came up with this. Whoever came up with it, place value system, every 3 places is 1 period, and you use a comma. So that's so confusing, I think, sometimes, because you're talking about a period, but you're using a comma. The only time we use a period is when we're talking about decimals. So I know it can be really confusing. So we're talking about the ones period. First off, the first blank, the first place value names that period. Some people call this the hundreds period. Some people call it. I call it the ones, but if you called it the hundreds, I understand. But typically we go with this place. So you see it's in green, ones, tens, hundreds. Okay. The next period after that, think for a second, thousands. This is the thousands period. See, the first place in that period, these are blue, names the period. So this is the thousands period. We got the ones period, the thousands period. Then after that, numbers go on forever. I'm sure you've heard of infinity before. The numbers just keep going, going, going. But you need to know at least to the millions. So we have millions, 10 millions, 100 millions. So if you notice, there's a pattern: ones, tens, hundreds, thousands, 10,000s, 100,000s, millions, 10 millions, 100 millions. And if we wanted to get crazy and go to billions, it would be billions, 10 billions, 100 billions. So it's a pattern. There's three place values in each period. They all deal with a ones place, a tens place, and a hundreds place for that period. Each time we move a digit, so there's a 0 in the ones. The 0 in the ones is, and the 0 in the tens, this 0 is 10 times bigger than this one. 10 times 0 is 0, Mr. Metters. That's why 0 isn't worth anything. It's a placeholder. And then the 0 in the hundreds is 10 times bigger than this. The 0 in the thousands is 10 times bigger than the hundreds. The 0 in the 10,000s is 10 times bigger than this. The 100,000s is 10 times bigger than that. And then we're all the way out here in the ones. So if I had a 1 right here, if I wanted to trip you up, if I wanted to put a 1 right here, okay, a 1. This 1 in the millions is 10 times bigger than the 1 in the 100,000s. Okay, so if I could write it like this: 100,000 times 1. Or, sorry, 110. So 100,000 times 10 would give me a million. So every place, I'm gonna uncover this rule. I think it's good for you to know. Every place, each place in a place value chart has a value that is 10 times as great as the place value to its right. So this place is 10 times bigger than this place. This place is 10 times bigger than this place. It's always going to be 10. So when you get ready to do the study island, they're going to ask you all kinds of questions, but it's always going to be dealing with 10. We're dealing with powers of 10, 10 times bigger. So 1 million is really equal to 10 times 10 times 10 times 10 times 10 times 10, or when you get to middle school, 10 to the 6th power. So this you don't have to know right now. It's just above, but some of you like to go that extra step. This is what powers of 10s mean. But what I want you to know, what you need to know for 4th grade, is you got to know that every place directly to the left of the place to its right is 10 times bigger. It's always going to be, as if we keep moving to the left, it's getting bigger. This place is 10 times bigger than this place. This place is 10 times bigger than this place, and just so on and so forth. Each place on a place value chart has a value that is 10 times as great as the place value to its right. Okay, now let's talk about this. Hey, I'm here. I'm back. So I can recognize that a multi-digit number, a digit in the ones place, represents 10 times what it represents in the place value to its right. Okay, so when you're doing this, you could have it pulled up and do a side-by-side split screen. It'll be easier, and you could fill this in while I do it as well. So I'm going to do a text box right here. Compare the value of the 8 in 1,324,968 to and 681. So when I say compare, I'm using the symbols greater than, less than, or equal to. That's whenever you hear compare, you need to be thinking those symbols. So it's going to be one of those three. So when we see 1,324,968, we think, whoa, that's huge. And 681, wow, that's little compared to that one. If we're talking about the whole number, you're exactly right. But we're not. It says compare the value of the 8, the digit 8. So the digit 8 in 1,324,968 is equal to 8 ones. The value of the 8 in the number 681, the 8 is in the tens place, so that means it's equal to 80. So if we're talking about these numbers and we're not comparing how big this one is and how big this one is, we're comparing the 8s. Which one has a bigger digit 8? The 8 in the tens place, the 80. So then the gator mouth opens, the greater than sign opens to the bigger number. So we compared those. 8 in this number is smaller than the 8 in this number. These are called digits. When you put them in different places, they have a different value. So then we got to talk about why. The digit 8 in 681 is 10 times bigger than the digit 8 in 1,324,968. Wow, what a good answer, Mr. Matters. All right, we've got to keep going. All right, so we're going to do a text box for this one. All right, it wants us to label, compare the value of the 8 in this and 681. So what is the value of my 8? So the 8 in this one is equal to 80,000. All right, text box again. I'm just going to go ahead and copy a text box. That'll save me some time. Oh no, that's not what I wanted to do. Never mind. Okay, we'll just do it this way. So the 8, there's an 8 in the thousands place, so I'm going to write 8,000. Spell it correctly, computer. All right, so I got another text box here. So the 8 is in the 8 ones, so it's 8 ones. And then I need one more text box. This is, you got 681, that would be 8 tens. All right, compare the value of the 4 in 82,364 and 641. Same thing as before. I'm just going to copy this, and I'm going to change, try to save some time here. Power of technology. Okay, so the 4, that's 4 ones again. The 4 in 82,364. And then the 4 in the tens place, that's 40. The digit 4 in the number 641 is 10 times bigger than the digit 4 in, I have to erase this number, 82,364. All right, one more to go. Text box. One more to go. There's 4 more problems, Mr. Matters. We have the 4 in 82,364 and 128,461. Okay, so we have 4 ones, and then we have 124 or 28,400. So we have 400. So obviously 400 is bigger than 4. The digit 4 in 1,200 or 128,461 is, now it's not 10 times bigger. They try to trick us on this one. We got to look at the places. The ones place, hundreds place, that's 110, 210. So 10 times 10 is 100. It's 100 times bigger than 4 in 82,364. Okay, so what's the value of the 4? They've got one hidden up here, so don't miss it. 43,000. So that would be the value is 40,000. Or you could have gotten crazy with it and wrote could have wrote 4 10,000s. I'll do that now. Hey, I spelled thousands right this time. All right, so then right here, we're looking for the 4 ones. There's 4 in the hundreds place, 4 hundreds. Again, we got 4 in the thousands place, 4,000. And then we've got 4 in the tens place. Oh no, we messed it up. Why you being like this? Computer, why you gonna mess up on me? Embarrass me for all these kids watching. All 3 of them. 4 tens. All right, so those are your notes. Once you have finished, be sure to turn in this assignment so that we see that you have done it. Hopefully, you've been doing it with me. You can always rewind, go back, and look at it again. Thanks for watching this video and learning about place value. I know it was so exciting. All right, peace out. I'll talk to you later.